Good morning, everyone. I hope everybody is doing okay. I am sorry about the delay on getting 605 to you. Sometimes as teachers, we need to go back and review the material as well. All right, we're moving into radians, and that's something new for all of us, okay? So let's get into this lesson and see where we are. Quiz Help 6.05. All right, so we start off talking about the circumference of a circle. We know the circumference is the measurement around the circle, and we can achieve that two ways. All right, we can use circumference equals diameter times pi, or pi diameter. We can also use circumference equals 2 pi radius. Okay, we know that 2 times the radius is equal to the diameter. So we're still using basically the same formula. It just depends on if the problem gives us the diameter or does it give us the radius. In this case, it gave us the circumference itself, and they want to find the diameter. Well, if we have the circumference and we want the diameter, then we're going to use this formula, and we're just going to back into it, okay? So we're going to take circumference equals, normally it's pi diameter, I think. All right, so we are given the circumference right here is approximately 44 inches. So 44, why do they say approximate? Do you guys know that? Why do they say approximate? They say that because we have pi in here, and anytime we have pi, we have an approximation, okay? All right, so we want to isolate the diameter, so we're going to divide by pi, and I'm just leaving the pi symbol in here because we're just going to stick that into our calculators, right? We're just going to put it in just like this. We're going to say 44 divided by, hit the second button and then the caret button, as we call it, and it's going to give us pi, and then hit enter, and it's going to give us 14.00563499. Okay, it's an approximation. Okay, so it is going to be 14 is equal to diameter. All righty. Pretty simple, right? Had we been given the radius that we wanted to find, we would have simply done this and divided by 2 somewhere along the way. All right. Next one, it says an arc on a circle measures 295 degrees. The measure of the central angle in radians is within what range? All right, so let's go back to square one just a moment. When we're talking about radians, let's think for a moment in terms of measuring the length across a room, okay? We can do that in inches. We can do that in feet. We can do that in yards. That's all standard measure, right? Okay, but we can also do that in meters, centimeters. Centimeters and meters is really the most common that we use here in America. Okay, it's just 2 different units of measure. Well, when we're talking circles, you have degrees and you have radians. It's just 2 different ways to measure. Now, one of the easiest ways that I found when I was in school to do this, it's kind of like, okay, unless you want to memorize the entire, what we call the unit circle, is learning how to build a unit circle. What do I mean by that? Okay, so 360 degrees completely around the circle, you were told in the lesson, is equal to 2 pi radians. Okay, so if that is the case, then at 180 degrees, you have simply pi, right? 1/2 of that. All right. So if you go to 90 degrees, well, 90 degrees is going to be equal to half of 180, right? So pi over 2, right? Yep. Okay. And if you go down here to, that would be like 1/2 pi, and here's a whole pi, and here's 2 pi. So this would be at 270 degrees, this would equal to 3 over 2 pi, 1.5 pi, right? Okay, that's really all we need at this point, because if you look at your answer choices, what they have done is they have divvied up the unit circle 0 to pi over 2, pi over 2 to pi, pi to 3 over 2 pi, and then 3 over 2 pi to 2 pi, okay? And look, it's just like what we were talking about. Here we go, 90 degrees, 180, 270, and 360, a complete circle. Well, a complete unit circle is 0, pi over 2, pi, 3 over 2 pi, and 2 pi, okay? All right, so it wants to know an arc on the circle measures 295 degrees. What range is it in? What quadrant is it in? 295 degrees. Well, you've got 90, you got 180, you got 270. So 295 is going to be somewhere around in here, right? It is going to be between 270 degrees and 360 degrees. But it's also going to be between 3 pi over 2 and 2 pi radians. Okay? All righty. Now, I'm going to, give me one moment. I want to nab what I just did with this unit circle, because I want to use that on the next page as well. All right. Okay, let's see if it's going to let me do this. Okay, why will it not let me do this? I'm not sure. It's not letting me copy it to this page. Okay, I have no idea why. I guess because I'm in Zoom. I'm not, oh, that's why. There we go. There we go. Had to take the draw off of it. All right, so it says arc CD is 2/3 of the circumference of the circle. So it's 2/3 of the circle. What is the radian measure of the central angle? All right, so we want 2/3 of the circle, right? Well, we could stop and think and divvy this up. 2/3 of 360, okay? If we divide it by 3, we get 120. So that would be 240. So we're talking somewhere around in here, correct? Okay, if we were given the range, but we're not given the range this time. They actually want to know. All right, so how are we going to do that? Okay, well, we want 2/3 of the circumference. We know the entire circumference is 360 degrees, right? And we know that a whole circle is 2 pi. So if we want our answer in radians, we're simply going to say 2/3 times 2 pi, right? We want 2/3 of the entire circle, and simply multiply. 2 times 2 is 4 pi over 3. Boom. 4 pi over 3 radians. All right. Next one. Okay, minor arc KL measures 135 degrees. Which is the radian measure of the central angle? Okay, now let's see. How can we do this? we've got 135 degrees. Well, we know our whole circle is 2 pi, right? We want our answer in radians. So we need to find our fraction of the whole circle. Well, we have, it measures 135 degrees. So 135 over 360. Let's find the fraction. Now, are there fancy ways we can do this? Absolutely, but here's how I do it, just off the top of my head. I see a 5. I know it's divisible by 5, right? So I say 5 into 13 will go 2 times, and that leaves 35. So 27. And 5 will go into 36 7 times with 1 left over. So 5 into 10 is 2. Well, I know that'll simplify. And I know that 9 goes into 27 and to 72. So that's going to give me 3 over 8. Now I'm in simplest form. Okay? So I want 3/8 of this circle, and I know this circle is 2 pi radians, right? So I simply multiply. That gives me 6 pi over 8. Now I have to look, that can be simplified, right? 6 over 8 equals 3/4. And boom, there's my answer. Super simple. All right, so this is 3 pi radians. 3 pi over 4, I'm sorry. 3/4 pi radians. All right, let's stop and think about that just a minute, okay? Remember, a diameter is 180 degrees and it's equal to pi. Okay, so look where K is. About 3/4 of the way around that semicircle, right? Making more sense to you now? I hope so. All right, consider circle T with a radius of 24 inches and theta at 5/6 pi radians. Okay, 5/6 pi. That means a little less than 180 degrees, right? All right, so what is the length of the minor arc SV? All right, so we see this arc, and this arc is not sitting at halfway, right? Okay, so let's do the multiplication. And what is our formula for this? Well, our formula for this, for our arc length, remember the lesson uses S for our arc length, and it says to multiply our theta times the radius, okay? So arc length equals our theta here, our length of our arc is 5 pi over 6 times our radius is 24. We can do this on our calculator, or we can simply do a little cross-canceling first. 6 will go into 6 1 time and into 24 4 times. And 4 times 5 is 20 pi. And this is inches. Okay, because we are getting the length of a minor arc. All right, so 20 pi inches. And there you go, guys. Good luck on 605.